Hello, hello. Welcome to A plus Leetcode challenge. Today's problem is triangle. Given a triangle array, return the minimum path sum from top to bottom. Basically, we're given an array that represents a triangle, and we want to find the path that's going to equal the minimum sum from the top row to the bottom row. So for each step, you may move to an adjacent number of the row below, but that basically means we can move either left or right, or either the index I or I plus 1 on each row. So this problem really reminds me of the minimum path sum for a binary tree. Say that we had a triangle that looks something like 1, 2, 3, 4, 5, 6, something like that. And this is what it would look like as an array. Let's try and make it look more like a triangle here. How can we solve this using just O of n extra space, where n is the total number of rows, not the total number of cells, number of rows. Well, I'll do one better. Maybe we don't even need to use extra space. We could adjust the triangle itself. So what we'll do is start with the very second to last row, and we're going to check below right here, because these are the two paths that we can go, right? Well, take the minimum path, or the minimum number between them, and add it to the number that we're on here. So at 2, which one's bigger, 4 or 5? Well, 4 is smaller, right? So add that here. And with 6, 5 or 6, which one's smaller? 5, right? So we'll update that as well. Now we'll move up to the next row and do the same thing. Which one's smaller, 6 or 8? 6 is smaller, so we'll add that to up here. And this is 7. And is that answer correct? Well, I think about it. If this was 2, 3, 4, 5, 6, yeah, it's like 4 plus 2 plus 1 equals 7. And that would be our answer. So this is kind of like a top to bottom approach. And we don't need extra space then. We can just adjust the triangle that we have itself. So let's do that. Let's start off by initializing n to equal the length of triangle. Next, we're going to have a nested for loop for the row and the range of starting at the second last row of the triangle. So that's going to be n minus 2 all the way to the top. And we're also going to have to go for every single cell inside a row, and that we can calculate by the row that we're on. We're just going to say for the column in range of row plus 1. So now what we need to do is update our triangle at the row at C. We're going to plus to this cell the minimum between triangle R plus 1 and C, and then between triangle R plus 1 and C plus 1. Once we finish that, all we need to do is return the very top row cell. So that'd be triangle 0, 0. So let's see if this works here. And it looks like that's working, so submit it. And accepted. So time complexity wise, this is going to be n times n, considering that n is the number of rows. It's actually n times n squared divided by 2, but that would actually be the same as n squared. But we use constant space. We use O1 space since we're just updating a triangle here. Well, just to be clear, let's just say that for some reason we weren't allowed to mess with this original triangle. Then we would need some sort of other data structure to like store this information here, these two rows, right? So if we could do that, we can do that as well. We could say store the current row and then the next row. We're going to start at the very second one, right? So this would be triangle, let's see, n minus 2, and this would be triangle n minus 1. Oh, this is going to be n minus 2 here. So everything else would still pretty much be the same. What we do is say get this next row here. We don't need this anymore since it's only going to be a single array. And we store current row here. And we don't need R anymore either. But the only thing we need to add is to update our current row. I'm sorry, the next row actually is now going to equal the current row. And the current row is now going to equal to triangle what? R minus 1, I believe. No, it's just R, triangle R. But at the very end, I think we just need to return the next row's 0. So let's see if this works. Oop. Okay, I messed something up, so let's check. What did I mess up here? Oh, I messed up something. Current row is going to be the next row. Then once we finish that, the next row is not going to be equal to current row. I think it's actually r minus 1. Yes, okay, so that was my mistake. It is r minus 1. Just go and submit this. And accept it. So this is actually same time complexity, but we don't modify our original triangle. We just store that information here in some array. So that works too. Okay, well, hopefully this helps. This is kind of a top-bottom approach. You can certainly go bottom-up and do something recursively. It would still be the time. I believe it'd still be the same amount of time complexity, but I think this is a lot more understandable and more clever. So, okay, thanks for watching my channel. Remember, do not trust me. I know nothing.